All right, let's take a look at some of the combustion and ventilation air sections, and we're going to specifically focus on this discussion. We're going to do this on Category 1 venting design or vent design. So this will relate to a little bit in the codes as well. So let's get it started. So there are a set of questions that goes with this. The M2623 set of questions related to design, and if you want to do those as you go along, that might be great. So, all right, so list the 4 main categories when designing a vent system. So the first of the bunch, or the first 4, or the 4 that we're going to deal with, is number 1, I want to have a vent system that has fairly low resistance so that I allow my gases to flow out of them. So that's kind of an easy task if you stay within the limits of the table, but that's generally the idea. We want to make it as easy as we can to let those systems flow out. And it's more than just sizing. It may be something the way you install it, or the pitching, things like that. The second one is small mass for quick warm-up times. So you want something that heats up fast so you don't get all the condensation. The third one is you hope that your vent system has good properties of insulating to make sure that the flue gas temps stay hot enough to keep the vent system warm enough so that you don't run into a condensation problem. And of course, properly sized. I want to make sure that it's sized for the job that I need. So this is somewhat of a little bit of a recap. I talked about this earlier, but what is exactly a vent connector? So the vent connector is essentially the portion of that the vent system that connects the appliance directly to the common vent, or the main vent is the way that it is. Now, vent connectors, there are some rules. The rules with with your vent connectors. So the first rule is keep it as short as you can. There are limits to how long you can do a vent. Or let's say the vent connector. So you want to make sure you're within those rules. They're pretty liberal, but when you start getting to multiple appliances, you got to be a little bit careful with that when you deal with multiple appliances and related to vents. So let's take a look at the next one. So we can also, with a vent connector, typically a lot of people will try to use single wall, and it's simply, single wall is so much easier to work with for cutting it or trimming it or trying to get it to the exact length that you need. Whereas double wall, you don't really have any adjustability. So that can be a little bit of a challenge. So usually there's ways to make it work so you can use a single wall vent, single wall pipe, and maybe run B vent all the way out this far up until you reach maybe even just a little stub right here. You might be able to use a short piece of single wall. So there's ways to do that to encourage proper venting, but that is what is needed. Another thing is you want to pitch it. You always want to pitch it upward at least a quarter inch per foot. So if you can do more, that's that much better for the most part. So just keep an eye on that. Try to get it as few of elbows as possible. The tables in the code book are going to allow you generally up to about 2 elbows, but then beyond there, you're going to have to start reducing the limits of the table. So there are some reductions that you have to do. Small appliances, they also connect directly to the main vent above that larger appliance. So now this picture might be a little hard to see that, but the smaller BTU appliance is supposed to be directly above and not directly across from one another. So you don't want one spilling in from the other appliance. So there's some rules of that. So good design would follow these. Clearance from combustibles is another issue. So this one's a really a big one related to the design of a system. So most of our systems, beyond the vent connector, single wall will not be allowed to be used. So in this example, we're showing a common vent that would likely be a double wall. These could be single wall or double wall. Obviously, double wall would be preferred. We can put a double wall vent pipe directly through a floor or through the roof or any of those with as little as about 1 inch of clearance all the way around from any type of a combustible material. Now, combustible materials can also include insulation. So most of the time, the inspectors will require that you have like an insulation barrier that would extend beyond the fire stop, and then that would prevent any insulation from coming in contact with that particular system. So the fire stop is going to be a device that's going to prevent you from allowing any air within reason to make its way through that penetration in the floor where you're running that vent pipe in. So the clearances from combustibles typically range anywhere from 1 to 3 inches. In most all of the systems that I have seen, they've always been closer to 1 inch as opposed to 3 inch. So typically, as I had put a note on here, about 1 inch is fairly normal. That's typical. So those two big things: your fire stops and your clearances from combustibles must be adhered to. Okay. Let's take a look at the next one, the pitching upward a 1/4 inch a foot. So I had mentioned about your vents or the vent connectors, but this also applies to even common vents. So you always want to try to get upward, get it sloped upward. The more the better. You're going to get better movement of your gases to make its way out. Now, this example I'd like to just show you. Here's a 16-foot span between this point right here and this point right here. So 16 feet, and you need 1/4 of an inch per foot. You could basically take a quarter, every foot, 16 times 0.25 inches to come up with a total of 4 inches. So you need 4 inches of rise from point to point. So as you're installing a vent system, it's very easy to make marks or to adjust clamps or brackets or anything like that to ensure that you're adhering to those rules. All right, and obviously the question, I've kind of answered it here, is why are the vents sloped upwards towards the vent for the gravity systems, and this is the reason. We want to promote a proper gravity flow of flue gases so that they will exit that vent system. All right, the vent connectors. So when you're piping a vent connector, there are a lot of choices. Not everybody makes good choices when it comes to those. Now, when we look at these 3 images on here, one of the things that you will notice is the first one on this one here. This one is really streamlined. It's a good system. They use 45-degree angles. You can use less than a 45, but I mean it's 45 is preferred. So you're definitely exceeding the 1/4 of a foot. So when you are using the next one, this 90, the one where you're rising up vertically out of the vent connector at the appliance outlet, and then you're rising up, and then a 90 directly into that, that's also a possibility, and it will work. But it's going to have that a 90-degree angle is going to be more restrictive than the 245s, and primarily because of the slope that is existing right in this pipe right here. This one is you're gaining momentum, you're building momentum. So those are really the best way to do that. The one over here, this looks like one of those bad venting applications where you're seeing the squirreliness of your 90s. So this is clearly one where a person in their right frame of mind, as they're installing it, they're thinking, oh, I'm going to really make this nice, and I'm going to hug the vent or hug the ductwork and make its way over the common vent. That's a horrible application there. There's way too many elbows. You're really killing that vent system. So what about headroom? So I wanted to show you in this example, what we're looking specifically is what should we do to this T? Where do we connect to that common or to the main vent? And you have choices. One of the choices would be, let's keep it nice and low so I can get at it, or I can get it up super high as I can near the ceiling. And the best application is definitely get it up as high as you possibly can. That's really your best application. So a little guy over on the right says, I love it. He wants to get that thing going. So this way you're coming out of this appliance, you're building momentum. It's really a good application here. So keep that, that's a good practice. All right, so let's talk about the lengths. Dedicated length of a vent and also vent connector laterals. So the rule of thumb on a single appliance system is you can go 1-to-1 ratio. So what we're telling you is if you've got a system that's 30 feet tall on your vent system, you're allowed up to a 30-foot lateral. Now, that's a lot of lateral. I mean, you do everything you can to try to avoid that, but the codes allow you to do that. So 1-to-1 ratio on there. So what is it called when you're only venting one appliance? Well, they'll call it a dedicated vent, and that's what this is. It's a dedicated vent. That one vent is only dedicated to that one appliance. Very exciting, very exciting. All right, so let's take a look at some of the rules for common venting. So I've listed on this image here a couple of pictures, and I've got two appliances connect to a common vent on this one. The higher, again, the smaller appliance always has to be the higher connected appliance. So unlike the pictures that I was showing you a little bit earlier, they didn't look quite like that. But that's the rule, is it has to be connected that way. The T-fitting is nice and high. That's all typical. Double wall is recommended. All those things are very applicable, very pertinent on here. So let's take a look at some of the things. So B-vent preferred on all the connectors. Connectors from the smallest appliance should have no more elbows than the connector from the largest connector. So again, I'll reiterate that the connector from the smallest appliance, that would be the water heater, should have no more elbows than the connector from the larger appliance connector. So that would be this other one. So in this one, they each have roughly about 2 elbows. This one has 2, so it's all good on that one. The smaller appliance should have the shorter horizontal run, if at all possible. I think, again, these are suggestions, these are rules. They're not hard concrete rules, but it's advantageous if you do that. It's good practice. Smaller connectors should always go to the main vent at the high point. I talked about that one. And then this one I haven't talked about, is the T fitting in the main vent should be the same size as the main vent. So this T and I'm specifically talking about this, there's actually, you can almost say you could have 2 T's there, but let's say the 1 T right here. So if this one here happens to be a 3-inch, and this one here happens to be a 4-inch, at an absolute minimum, you would want to have at least a 4-inch at a bare bones minimum. You wouldn't put a larger connector into a smaller pipe at the T, so that would not be the case on there. So, and you can, they make all different sizes on there. Now, if they only make a T that has let's say it's a 4-inch T, then you're going to have to use a reducer right here to go 4 to 3. So those are the cases that you have to deal with. All right. How about the maximum connector, maximum common vent connector offset length? Now, in a manifold system, what we're showing in this example is that in a manifolded system, they give you, the rule is that you're allowed 1.5 feet for every inch of vent size diameter. So that's 18 inches. So in this example, if I happen to have a 6-inch diameter system, I'm allowed a maximum of 9 feet as far as the offset at an absolute maximum. Again, there's so many rules in these, in all of these venting applications on here, but that's kind of one of them, is a maximum offset before you reach the double on that. So what I pulled out here is I threw in here an excerpt, table 13.2.2. This is out of your code book, out of the 2018 National Fuel Gas Code Book. And what they're showing is the maximum vent connector is 18 inches per inch of connector. So if you look at it, if you've got a system, an appliance that's going to use a 5-inch diameter connector, they are going to allow you up to 7.5 feet of connector length. So that would be your vent connector length can be no more than 7.5 feet. That's typically not going to be an issue, but it does sometimes, present a problem for you. So if that's the case, you may have to upsize the vent connector to allow you a longer, to give you a little bit more opportunity. So a 6-inch would allow you up to 9. So, but this is straight out of your code book. You guys will be able to look at that later if you do some of the problems. So again, watch the rules. One of the other rules to also mention here is that if indeed, if any of the connectors exceed that length, you'll have to exceed the 1.5 times diameter rule. You're going to have to derate the table that they're showing you for each length of limit and recalculate those connectors. So I think again, you're going to have to go down on the table because you're killing some of the momentum by going longer. That's one of the things. Or you can just use a larger connector on there. All right. So how should the main vent be designed? So let's take a look at some of these. So the pictures, you can kind of see what's preferred, what's acceptable, and what's poor. And in this case, keep it as streamlined as you can. Make it as best as you can. If you have to have an offset, that's, and this is fairly typical. You almost always have to have that. But if you have to have some sort of a venting offset that's shown here, you may, sometimes you just can't get away from that. That is acceptable. Using 90s would be really not preferred if you can help it. So as you can kind of tell, you'd rather have the 45s than the 90s, as you can tell. Keep it as straight as you can. Having a vent system specifically like this one where it's straight up and down is really rare. So you have to kind of do what you can in that case. Again, use good practices. So don't use any unnecessary offsets, and then again the 45s over that. All right, so how about some rules for termination? So here I've got a vent termination height that we're going to look at, and I pulled an excerpt out of the code book for this that talks about the roof slope heights. And so what happens, you have roof pitching on a typical structure in this particular area, and the way that it's the way the roofing pitches are set up is they talk about the rise over, in this case, the run. So if you happen to have a 412 roof, that would be, you'd be going up 4 inches over the 12 inches over. So, and then in this case, that would be 4 as an example. So that's about the lowest you generally see in this area for any type of a normal application on a sloped roof. Of course, a flat roof is different. So the way that this works is they tell you that if you happen to have a system, and this is, oh, by the way, this is also for anything 12 foot or less, 12 inches or less, yeah, and you're at least 8 feet from a wall, a vertical wall that's in the vicinity. So that's what these pertain to. So if I happen to have let's say a 612 roof, I could get by a 612 roof pitch. I could get by with as little as 1 foot above the roof, and that's from the highest point leaving the roof. So that would be shown as right here. That would be 1 foot. The higher you make it, the better you're gonna be to a point. If you go too high, then you got to start putting guy wires on it. As you can see, the more slope, like in this case a 12-12 pitch, you could get by with as little as 4 feet of vertical height leaving the roof. Again, that's what you do for those types of vents. So an example here, 10-12 pitch roof, minimum, if I ask you what is the minimum termination height above the roof, it would be at 10-12, the minimum here would be 2.5 feet of rise out of the roof as shown in there. Again, more is better. So let's take a look at some more termination rules. This is probably one of the harder areas of understanding the rules in the code book or out of the code book. So I pulled a few of them, the pertinent ones out of the code book. And so in the 2018 National Fuel Gas Code Book, 12.7.3, gas vent terminations. Terminations shall comply with the following requirements. So a gas vent that would be 12 inches or less, located not less than 8 feet from a wall or similar structure, shall terminate in accordance with that previous table that I just shown you. The gas vents that are more than 12 inches in size or are located less than 8 feet from a wall, they shall not be less than 2 feet from anything within 10 feet horizontally. So that's another kind of a basic rule that sometimes people use. So 2 feet higher than anything within 10. And then a B or an L vent. A B vent is essentially aluminum interiors. An L vent is more of a stainless steel inner lining. They shall terminate at least 5 feet in vertical height above the highest connector. So that's kind of describing you the minimum vent height is typically about that, of at least 5 feet higher than the appliance outlet. And a BW vent. A BW is an actual oval vent to fit inside of a wall. So those vents, specifically like for a wall furnace, they shall be at least 12 feet in vertical height above the bottom of a wall furnace. Now most wall furnaces are 5 to 6 feet tall anyways, so again it's similar heights. And then of course the fifth rule that I put on here in summary is a gas vent shall terminate at least 3 feet above a forced air inlet located within 10 feet. So you got to be careful so you don't have a combustion air, something that's supposed to be bringing fresh adequate air to a building, and then having it terminate too low. So you want to make sure you try to stay away from those as best you can. Best is just try to get your vents away from outside air intakes if at all possible. So those are codes that you have to follow. Again, there's a lot of rules in there. Here's another couple of things, and this is similar to the one that I just referred to about, if you're within 8 feet from a wall, you got to be 2 feet higher than that, regardless of what that table told you. These other ones on the far right side, you can see they're not really the best applications. To go up alongside of a building is like this would be terrible over on this side, and this one way too close to this. So those are examples of that if you can help it. Here's another one of these vent rules for vent terminations on 12.6. Now, what's confusing is because they don't easily or clearly in the code book differentiate chimneys or from a vent. So you'll notice 12.7 versus 12.6. So masonry, metal, or factory built chimney. So these are specifically identified as a chimney that meets certain requirements. They have to meet, they're just more engineered to some extent. On these particular systems, they have different rules on there. So this is an excerpt out of the code book that talks a little bit about now, they want everything 2 feet higher than anything within 10 feet. And 3 feet higher in this example, above the highest point we're past through a roof, 2 feet higher than anything within 10 feet of the. So again, I think, without getting too techie on this thing, I think the general rule is if you can try to get a vent system, if you're within 10 feet of anything, try to get it 2 feet above that is generally a good rule for your chimneys. Again, a little bit higher typically means a little bit better. I've used this as a practice in the field as a corrective measure, that if I ran into an application that was having troubles venting, sometimes the best fix is to add a small or a short section of vent pipe to extend it up a little higher. So and you're not going to probably be able to do that with a masonry chimney, but here's another really nice picture to describe the previous images to show what they should project out of here. So why are all these rules? Why do they have all these vent termination rules, and why do they make a big deal about the vent height? So what do you have to have? Well, a lot of this really is about they're trying to prevent the wind or these currents from affecting the natural draft out of a vent. Now, there are a couple of types of draft that we have to deal with in a vent system. One of them is what we call currential draft, and that's essentially when the wind blows over the top of a vent, you're kind of expecting a little bit of an induction effect that would pull those gases out of a vent system. But there are times where you can get some goofy wind currents that will flow and disrupt the venting powers and the natural draft of the vent system. So that can really be tricky. So a lot of those rules are written around there. But even if you could follow it to the T, and you still could have problems with that. So just because you followed the code doesn't necessarily mean that it's always going to work. There are odd situations where you could have a tree in the vicinity. You could have that's affecting the wind currents. It's really tricky to do these things. So you just have to try to do the best you can at following a lot of these rules. So let's talk about the vent sizing table. So the first thing I want to hit up on here is this. We have on the single appliance systems, that's where you have one appliance, one vent system. They have tables 13.1A through all the way 13.1F. Those are single appliance systems connected directly to the vent. Those apply to B vents, masonry chimneys, and also B vents or single wall metal connectors that would apply to those types of systems is the way they have. Then the other codes are table 13.2A through 13.2I, and those are all for two or more appliances that would be connected to a vent system. That also applies to a B vent system or a masonry chimney. So the B vent, single wall metal vent connectors, they would also include the sizing of the vent connector as well as the sizing of the common vent, what I'm calling the main vent. So those are all part of what those tables are. So it would be probably advantageous as you're going through this, even to pull out your code book and take a look at the what is actually in there, what they look like, and all those types of things. I'll have some examples coming up. So when you go through, so we'll go through some of those descriptions a little bit in here. So in the table, so here is table 13.1A out of the code book. And in your code book, if you looked at the one that I'm looking at, that would be on page 5497, 54-97 on the 2018 code book. All of these tables are for category 1. I'm going to remind you. They are not for category 3, they're not for category 4 or category 2. So a couple of things that I'll point out. Number one, up on the top, it says I have a single category appliance. I happen to have it's for category 1. It is connected directly to the vent. So what that means is if you're using a B vent pipe that would be in there, that would be connected directly to that vent. There is no single wall in this application. In here, they also identify the vent height. Now, this is the vent height of the common vent, is the way that would be. And so the common vent height is right here, and also the lateral. So you'll notice, remember earlier we had talked about that if I happen to have an 8-foot vent height, that I can go up to as high as an 8-foot lateral. So that gives you a little bit of an idea of what they're showing there. Additionally, the other things that I'll point out, you might notice that if I happen to have a 2-foot lateral, you'll notice that it expands the tables. So the tables, and for example, on the one that I had 8-foot, you'll notice on this one here that this one for a 3-inch vent pipe, it's allowing you up to 35,000 BTUs of a natural vent appliance. And if you had a 2-foot lateral, it's going to allow you up to 40,000 BTUs. So the less lateral, the better you're going to be on there. So you try to, that's why they say try to minimize your laterals. So some of the terminology: height, lateral. Now let's talk a little bit about this fan min and fan max. Okay, the fan min and fan max. The fan min and fan max pertains to a fan assisted appliance. That is category 1. Now the minimum would be, this is the least amount of BTUs I can put in a fan assisted appliance in a vent system that's going from that type of a system. And that's independent. So you're talking about one appliance. And then, so there's a fan min and a fan max. Part of why they did this is that, why they put a fan min and a fan max is you may have situations where when an appliance that's 2-stage goes into low fire, it may not meet the requirement. So you might have too low of BTUs. And this will become, that becomes a bigger issue when you start getting into single wall vent connectors, as an example. So, but that's essentially what we're dealing with. So pretty nice, easy little system. So the fan min and max are all for fan assisted appliances. The natural max is exclusively for the natural draft appliances that are not using a fan. And all these numbers that are shown in here, these are all BTU numbers. So they're talking about appliance input in thousands of BTUs per hour that is going into that vent system. So if there's, in some situations, you might have an excessive number of elbows, you're going to have to derate these table values for whatever it is that you happen to be doing it. So that means that if I had a third elbow on a system, that 35,000, if I had to take off 10% of that, if that's the penalty, then I would have to take off, and I'm going to specifically hit up on this one, is that 35,000, if I took off 10% of that, that's 3,500. I'd have to subtract 3,500 BTUs off of 35,000. So the capacity now would be only 31,500 in that example. So you have to kind of watch those numbers, and there's a little bit of figuring to do. All right, so some of the steps. So in chapter 13 of this code book, they talk about, determine the number of appliances that you're going to use. That's, in that vent system. Determine the appropriate venting materials. What do you want to use? What type of vent system is the application? What's the connector? Do you want to use single wall or double wall? Sometimes you may find that that single wall vent pipes are not going to work because the table values won't allow you to use them. So you got to watch that. Determine the height of your system. So any application, when you're going to connect up the vent system or put it in or design it and figure out what size you're supposed to use for your application you're dealing with, you're going to have to estimate what your vent heights will be. You're going to have to estimate what your laterals are going to be. You're going to have to find out what's going to go into the system to make sure it's going to work. And then obviously you're going to have to figure out what's the input of your appliances that you're dealing with. So the best way to do this is definitely go and look at the appliances themselves. And if those aren't given, it makes it awfully tough for you. You might have to guesstimate based on what typical ones are, but you should do the investigation at least to figure out, hey, I'm putting in a water heater and I think it's 50,000 or whatever it might be. You have to figure that out. So, and then figure out the appropriate connector, vent size, and all that for the input. So during that whole process, you really have to make sure you're reading through the rules that are in those. If you're dealing with single vented appliances, you got to read the rules. If you're dealing with multiple vent appliances, you got to read the rules. You got to make sure you know those. There's a lot of rules. I know it's not fun stuff all the time, but you do have to do the work on that. So here's an example. Just a quick little sizing example I'll go through with you. So here's an example where I happen to have a system where we use some offsets, and I've got a kind of a lateral initially of 3 feet, but overall the whole lateral of the system is actually 10 feet. So, and I've got a 20-foot high system. So we're actually measuring from the outlet of the appliance that's shown in here, all the way to where it exits the system. So that's really considered as my vent height. Okay. Now, let's take a look at the table value for just simple, as a simple example here. So this capacitor, this B vent, the type B double wall vent connector that's tied into here, we're showing a vent height of 20, which is one of them that we had, and we have a lateral of 10. So in this example, if this were an appliance that were, let's say, it's a 60,000 BTU natural draft appliance, that would be, I would try to go over on this all the way until I find that, oh, here it is, natural. I would look at natural max, and I would say, okay, that means the natural max, a 4-inch vent system, 4-inch vent pipe, would be capable of handling up to 89,000 BTUs. So as long as I am within the guidelines as far as the number of elbows, and I didn't exceed the lateral, which in this case I didn't, I should be in really good shape. The code books also differentiate between 45s and 90-degree angles. So if you have a 45, that would only have half of the resistance and the deduction that it would if it were a 3 elbows. So those are case. And then a 5-inch common vent system and connector, of course, would be that it would be up to 150,000. So you want to be very careful not to oversize. Don't put any bigger vent system in than what you absolutely have to. Now, let's talk about what if this were a fan-assisted appliance. So let's say that this were a 60,000 BTU fan-assisted appliance. Okay. Now, in this case, single stage. So in this particular state, I would look at it as you can go down to as low as 38,000 BTUs or as much as 133 with a 4-inch, and then you could go to 28,000 versus 64,000 if it were a 3-inch. Now, what will be the determining factor is if you happen to have you got to look at your elbows, and the other thing you have to look at are downsizing rules. Some of the rules in the tables will say you cannot derate a fan-assisted appliance, and if they do allow you to do that, if they do allow you to derate it or downsize it by 1, they oftentimes make you take a 10% penalty. Now, in this case, if this were the case, I quite possibly would have to derate this 64,000 and it wouldn't work if I derated it by 10%. So you have to kind of really look at those rules. Most of the time, like I said, the typical applications, you don't generally have an issue with that, but you have to look at what is recommended and try to make sure that you're not getting too cute with the numbers on here. So those are all good. And the last thing that I'll hit up on a little bit is, all right, so let's say that I did put a vent system in and I installed it the best I can, or maybe I'm doing service work. So, how do I verify if any of these were working correctly? So I threw a couple little images on here. The one on the far left is probably the simplest test in here, and that's really kind of a simple spillage test. And what you do is you can use, let's say, a burning candle or a burning match, and is it drafting? Is it pulling the smoke up into the vent system? And that's what you're wanting to see. In this image here, and I've used this as well, where I took a match and I lit it off, and I watched the flame get sucked towards the vent system, and that's what I want to see. If that flame were to be pushing this way, that would be bad. That would tell us, hey, we got a problem. It's not drafting right here. And then, of course, the next one is, of course, using a draft gauge. And if your draft gauge is going to indicate a negative pressure, which of course draft gauges can actually indicate positive or negative. You want them to be negative. If they show a negative pressure after you've been running it for, let's say 5 minutes, you run the unit for 5 minutes and then you do the test, as long as it's functioning properly within really within 5 minutes or so, it should be in pretty good shape. Now, obviously, you don't like to see that happen where you got to wait 5 minutes. Most appliances will try to build momentum, and they will draft much sooner than that. But 5 minutes is the bare minimum that you would need to have on that. So that's essentially how you would do that. That is the end of this particular lesson. Now, you probably have already done this, but you can complete the questions related to this particular one. That's number 23, and you could finish that and take care of that. I want to expand one step on there, and I had mentioned this. I put a note in there about, if you do get a failed test, let's say you've been running this thing for 5 minutes and it's just not drafting, you're going to have to do some corrective measures. You could have some problems where maybe you're not making up the air. Maybe the building is in such a negative that it just doesn't draft. So it really